Okay, so 3.2, linting. This is a fun topic. It relates to your week 3 labs and it relates to assignment 2 as well. So, you know, it's interesting. Some of you will be familiar with this topic, some of you will not. For those of you who aren't, it'll be quite interesting. So 3.2, testing linting. What in the world is linting? Well, we're going to get... David says I can bookmark the feedback link for quicker access later. Yes, I could, but I'm not smart enough to do that. Okay, so what are we doing in this lecture? You can't manually fix your style forever. We need automated approaches to do that. We're going to talk about linting, we're going to talk about PyLint. So like, if you go through the history of things, which we'll go through in a bit, you'll learn about what you did on 1511 or some other course is not what you might necessarily do at scale or in industry. But before we get into like the how do we manage style, let's just quickly recap like what is good style and why does it matter, right? When you think of style guide. Think of tabs, spaces, indentations, variable names, spaces between operators, all that kind of stuff when you learned when you started programming. So a quote to keep things all into perspective. Programs must be written for people to read and only incidentally for machines to execute. So I used to have this quote that I loved, which was like, code is for humans, right? Because when everyone starts programming, well, not everyone, when most people start programming, they think they're writing computer, right? Like even if you're not, it's like, it's this strange language, it's foreign, it's not English, it's not prose in any way. You feel like you're giving a computer instructions as to what to do. So it kind of feels like, it should be elegant and tight and efficient and everything like that, which sometimes might make you code with bad style because you think, oh, well, it's just a computer, it'll figure it out. Let's just make it nice and small. Code is for people. You write code for people. It gets compiled, it gets interpreted, whatever you want to call it, depending on the language you're dealing with, and computers then go and read other type of code. A computer does not read your Python code. A computer reads code that is like assembly, and there's another program out there that converts your Python to this computer code, but no computer looks at your Python code and says, oh, I know what to do. Your Python code is a giant string. Just remember that. A .py file is literally a giant string. A computer cannot understand what a giant string is. It has to have someone convert it. So you're writing code for other people. That's really important in everything we do. Why should you care about style? Why should you care about white space? Why should you care about function names, function styles, consistency, all of this? Because it's so much easier to read programs when you have a consistent style, right? And this isn't just like the simple things either. Like sometimes it's not just white space and semicolons and whatever else. Sometimes it can be even more detailed than that. However, I think what's really like imperative to make clear is that most of your interactions with programming so far, for many of you, have been very straightforward. You get given a blank file, you write code in it, you run that code, and then you forget about that code, and even if you have to go back and look at it, you wrote it like a few months ago in many cases. Many of you have only programmed since the start of 2021, like statistically, right? But in reality, what happens, two big things happen. One is you have to read code that you wrote a long time ago. I was trying to read code that I wrote 3 years ago and explain it to someone the other day. And I, like, this is some code, and I could not make sense of so much of this. It was like I was just reading it. It's a big math piece to do. It's like some financial math. And I was just like, I have no idea what some of this does here. And it's very poorly commented and all of this kind of stuff. And the style is okay. But the point is that you reading your old code or you reading anyone else's old code or new code is always going to be a struggle. So much of what makes code reading manageable for you is the fact that you wrote it and you wrote it recently. So you don't even need to try and read it because you know what it does. It's like in your brain conceptually. So style is really important to help take the edge off that like kind of horrific experience of making sense of code that you don't know or you don't remember. That's the point of good style. Now, good style alone will not make code readable. You need to have well-written code, well-designed code, and all of these things. But good style helps take the edge off. Consistent layouts, good commenting, these things just make it easier. This code has pretty good style in the grand scheme of things, maybe bar the comments. That doesn't make it easy to understand. It's still hard. But it's easier than it could be if everything was chaotic and there was, terrible style. So we like style. It makes it easier to follow the flow of code. It makes it easier to visually glance at similar patterns, right? If you have very well-structured code, you can see, function, function, function. It's all well laid out. And it's also easier to detect bugs, and that's one thing we're going to be talking about today. So if you have a good style, I've got an example here. If you force constants to be uppercase, because in Python, there's no such thing as a constant variable, right? A variable you can't modify. If you make all of your non-modifiable variables uppercase, then suddenly, at a glance, if you see that variable being modified, you're like, that could be a bug. So you can actually use style before the code's even compiled or interpreted to help minimize errors, and it's very simple and it's very great like that. Now, getting back to it, what is good style? That's a more interesting question, because we all probably hopefully get why style matters. I've hopefully just explained it. But like, what is good style? Okay, well, if you're young, so like typically people go through a few different stages, right? Like, and you see this a lot with programming. So you start off programming and someone says, this is good style, and you go, okay. And then you maybe get a year or 2, 3 into programming and you start to feel super confident. And then someone's like, this is good style. And you're like, no, it's not. This is good style. And then you get into fights about tabs. But then as you get older again, you start to realize that none of it matters. And then you just say, okay, again. That's not everyone, but that's a fairly standard pattern I see. So when you ask these questions about what is good style, snake case versus camel case, right? Like, remember, snake case is you got snake case equals 1, you got camel case equals 1, you have Pascal case equals 1. You have all these different things, Which of these two is better? For function names, for blah, blah, blah. Should you use tabs or should you use spaces? I have an opinion, but that doesn't matter. You have all these questions that come with style, but the only thing that really matters, the only thing that really truly matters, is that your style is consistent within a project, or often more broadly within a company or an organization. So the most important thing that anyone can do is follow the conventions set out, because again, the majority of the time that you work on software in whatever field you're dealing with, you're going to be working on an existing project, right? Some of you will be writing new projects. Some of you will start entire organizations of software. But majority, if you just statistically, right, end up working on software that's already started being written. And therefore, there's probably already going to be an established sense of style that has been handed to you. And therefore, you're going to stick with it because that's what's there. That's what has been done. And it doesn't really matter, because at the end of the day, getting a consistent style across a project is 100 times more important than a specific outcome of a specific style property. Just working backwards, Amir says Hayden was going to say tabs. I was going to say spaces. I used to be tabs when I was younger, and I got converted to spaces, but I don't really care. Again, that's the point. I'll work with tabs, I'll work with spaces, whatever the work I'm doing on dictates. That's pretty straightforward. So yeah, NK Pro, is there anywhere we can check how good our style is, like 1511 style guide file name? So we're going to talk about that in a sec, as some people have alluded to, and talk about ways to fix that. That's a shame that they tell you how good. I like the non-automated ways in 1511, but I'll let that topic die. Camille says, do you have any suggestions on how to have consistent code style when writing as a group? Yeah, so essentially, we will get to that. I'll probably answer your question in a slide or two, but generally speaking, one of the first things that has to happen, I'm probably going to talk about this, is like you just have to decide on a set of styles. So let's actually run through that. Who decides on style then? Here we go. So you got a project. All right, how do you figure out what style to use? What styles to do? Do you use tabs? Do you use spaces? Do you use any of this? Generally, you follow 2 steps, and the second step's optional. When you start a project, you'll typically pick a style guide that's written by some large organization. I don't even mean like a tech company. I mean like an organization could be like an open source body, or the Mozilla Foundation, or the IEEE or something. But it tends to be a large organization of volunteers or employed people, so like volunteers or paid employees. So you choose a style guide. Many companies out there have style guides for different languages. Like, I don't know, I've never Googled this before, but let's Google it. Facebook Python style guide. Sometimes they don't. And sometimes they use other companies' style guides. So most of the style guides that I interact with are in the world of JavaScript, in the web world. And a couple of the biggest companies that do that are Facebook, Airbnb. They're like 2 of the biggest ones. So, a lot of people out there will use like a Facebook style guide or an Airbnb style guide. And you think Airbnb, that's strange. But sometimes a lot of companies invest into these languages, and they have a particular style guide. Now, what's interesting with Python in particular about a style guide is that unlike some other languages, because Python is a very rigid language, and because Python has a bit of a, I would use the word orthodoxy about it, but I know for some of you that word won't mean anything, because it has kind of like a strict cult following about like what is good Python and what is not, right? And those opinions tend to be fairly well aligned. You can kind of find a general truth as to what good Python is and what isn't. One thing that's a bit different with Python is that there's actually a style guide dictated by what we call the PEP8 standard. I don't know if you call it the standard, but there's this term called PEP8. Sounds like a weird name, right? PEP8, okay. And who wrote that? Well, a lot of people. It wasn't a company. When I say a lot of people, I mean some people started it, but it's a style guide kind of generally endorsed by the broader Python community. So if you're like a Python fanatic, or if you're someone who just cares about the language following a fairly accepted set of principles and rules, then you're going to tend to use this style guide, which is called PEP8. It's a very strict style guide. It tells you everything like indentation. Use 4 spaces per indentation level. Okay, continuation lines should align wrapped elements either vertically using Python's implicit line joining, blah, blah, blah. There's rules that go on forever. This is the main style guide for Python. It's called PEP8. So typically you'll find a style guide like that, option 1, and then option 2 is sometimes you might optionally modify specific rules to satisfy any clear subjective opinions. So for example, right, just for example, let's say you start a software project with 5 people. What you would probably do if you're doing Python is you would say, all right, let's use the PEP8 style guide, because it's the PEP8 style guide. It's like the Bible for style in Python. But everyone in this group really hates spaces. So let's use tabs. So maybe you'll sit down and you'll change some of the rules at the start and say we'll use tabs instead of spaces, But it might just be a few things. You're not going to sit down and waste hours rewriting a style guide, and most of the time you're not even going to touch it. Because if you touch it, if you make it different, what happens when someone else comes onto your project? Either someone from, the big bad world or another person that joins to help out. They're going to be like, why is this so complicated? Why did you guys not just use PEP8? They'll be like, are you adults? Adults can deal with tabs and spaces. Adults can deal with these things, and you'll be like, blah, blah, and you fight about stuff that doesn't matter. So, generally speaking, you don't do that unless either the whole group has a big opinion, or sometimes what you're doing, the way you're using Python. I don't have a good example in Python, but the way you're using Python, it just like if you have tons of nested stuff, right? Like imagine you're writing Python, which many would call bad Python. That is just super nested, right? Like ifs and fors and ifs and fors, just like way down. Maybe you're going to want to change it to be 2 spaces, because if you have like 10 nested if statements, which by the way is probably just bad code, 4 spaces is going to make your code really unreadable really quickly. So maybe you'll change spaces to 2 spaces. Like these are the kinds of little tweaks you might do to the style guide. In COMP1531, the staff, us, use a standard style guide and we provide them to you. We provide it to you. I don't think specifically we use PEP 8, but that doesn't really matter. We'll get into that in a second. But we do provide one to you. Okay. In terms of actually checking or enforcing good style. So how do you enforce good style? So we talk about, why style matters, what good style is, but how do we enforce what good style is? And this is where the topic of linters comes in. So in early computing courses, you're told often to manually make sure your code complies to style guide. You go and fix some things up. Nowadays, I know 1511 uses some more automated stuff. I won't get into that. But in proper software engineering projects, we tend to do something that we call linting our code by using software that statically analyzes your code. So a linter is a thing that you take like a still object, and then you just like roll like a linter over it, right? If any of you have seen these, and it kind of picks up dust and cleans it up. It like looks at it, tries to clean it up. And that is what we call static analysis of your code. And linters are these things that do this static analysis. So what is static analysis? Well, static analysis is the process of analyzing your code before it runs. Right? When we say, dynamic analysis would be exceptions or something like that. Stuff that happens whilst your code is running. Whereas static analysis is pretty much just looking at your code as it is, looking at the source code directly. So I guess just to elaborate on this, it's like a C compiler. Like when you compile with GCC, compilers actually do static analysis. Like when they do things like type check, they say that's not an int, this is a double, and things like this. This is an unused variable. This is all static analysis. So compilers do a ton of static analysis. Because, oops, there's another typo here. These are all new slides. This one I will fix up right now because this one is just a dumb typo. At the bottom here I've got, what does it say? It says something silly. It says, silly. It says C at the bottom, which it shouldn't. It should say because Python is interpreted. Great. Yeah, so because Python is an interpreted language, right, which means that it's compiled and run at the same time. Because it's interpreted, linting helps bridge the gap that's missed out by some compilation. Because in Python, you just have the code and then it runs. That's it. But in C, you have that nice compile step that checks things. So in some ways, we're trying to fix this gap that's left in Python not having a compiler, where we can actually do some like compile-ish time checks, type checks maybe, something like this. Obviously, Python doesn't have types in it by default. But the two main things that linters do, and the two main things we're interested in with linting, are style issues, like a style guide, and what we call semantic issues. These are things that, again, typically a C compiler would pick up on, like unused variables, like variables that are used before they're defined, things like this. We call this semantic issues because the meaning of the code doesn't make sense. Maybe it looks good, but it doesn't mean the right thing, or it could potentially mean the wrong thing. So a linter is a static analysis tool. A linter doesn't just check style sometimes, it also checks semantic issues. It depends on the linter. Now we're going to talk about a Python linter called pylint. It's going to take us another 15 or so minutes, so let's take a break now. Let's take a 5-10 minute break. Week 3 onwards, I think. Well, this week we have a little bit of leeway with our time. But let's take a 5-7 minute break, come back at like 11:02, keep talking about pylint, and then before we start the next lecture, we'll talk about the leaderboard. So, 5-7 minute break. Cool. Hi, welcome back from the break. Cool. All right, let's get stuck into it. So, pylint is where we left off just before the break, and we were talking about like pylint as a mechanism we're going to use within the Python world to actually lint our code, right? So what the hell is pylint? Pylint is a command line tool. It's a program. This is a program to deal with Python linting. It is a popular external tool, where external is in you have to install it, it's not like built into Python, for statically analyzing Python code. You can detect errors, warn of potential errors, check against conventions, and give possible refactoring suggestions. So it does the style and semantic checking for us that we've talked about before. You can also configure it to have different levels of kind of sensitivity. So like if we look at a simple piece of code here, you know, let's create another one. I'll call this one hello.py because that's an easy name. And I copy this code. Now what you notice about this code is it's a bit imperfect, right? You might have an equals in the wrong spot. You've got inconsistent spacing with the commas. You've got spaces between the brackets in some cases and not. You've got, you know, 2-space indentation. And what happens is on the CSE machines, this will already be installed for you. But on your local machine, you can install Pylint just by doing pip3 install Pylint. Now again, this was installed as part of your big requirements.txt. We talked about this last week. And what how you can run this is you simply run Pylint and then your file like this. And this will lint your file and give you information about it. In this case, it comes back with a whole bunch of random things. It's like, okay, you can ignore this top line here. That has nothing to do with anything. Maybe I just remove that file. Is that a thing? Oop. Pylint hello. Okay, and what it does is it starts reporting to us what issues there are in your code. Hello.py on line 4, final new line missing. Okay, so your code should end with a final new line. Bad indentation, found 2 spaces, expected 4. Missing module docstring, constant name doesn't conform to uppercase style. So because we don't modify name at all, in fact, we don't really modify scores either. Don't know why it does that. Because we don't modify name at all, it should be uppercase, and then here, consider using enumerate instead of iterating with range. So this is an example of, I mean, most of these are style related. I don't think there's anything semantic here specifically. I mean, it will actually pick up on a few things. Like if you try and print the variable doesn't exist, it should pick up on this and say you didn't define it. So many of these are style, but you can actually see undefined variable here. This is a semantic issue. So this is kind of more akin to, you know, what you would normally maybe expect a compiler to do or something like that. So cool, really simple. You also get a score at the end, -12 out of 10. So 10 out of 10 is the best score you can get. -12 is not the best score you can get. That's pretty straightforward. As you get rid of issues, this one goes up. So let's get rid of the two space indentation and do 4 space. Okay, I ran it again, and what you notice here is I've gone up to -8. So I've actually got less issues now because I fixed up that kind of indentation. Now, Caleb says, what style does Pylint try and force us to follow? I guess I'll touch on that in a second too. In terms of fixing this up, a lot of the time, some of these things you might have to fix up manually, like, you know, say the uppercase name or something like this. And you can kind of just work through these and remove variables that aren't used and then add a new line at the end. I just added a new line there by accident. Consider using enumerate. Okay, so here it's kind of like, can you use enumerate? Sure. Enumerate scores. I don't know if I need that second argument, do I? Maybe, I don't know, I haven't tried to do that. So I think you might be able to get away with not including the second argument. Let's see, actually, I don't know if this will run. I've never tried this. Normally when I do enumerate, I use the ID and the value. I have a feeling it won't work. Yeah, so like, you know, linters aren't compilers. They won't pick up on literally everything. But in this case here, what's actually happening is, remember, enumerate returns you a list of tuples, right? So each time you return from enumerate, it's a tuple. When you do something like this, you're destructuring that tuple and extracting those values here like that. So this one works, but when you do this, it's actually treating IDX like the whole tuple. So it's a bit weird because then to get the actual ID, you need to get like the 0th element of that tuple, which is a bit strange. Another thing you can do in Python, I think, I don't write Python day to day, is if you ever need to destructure something, but you want to discard the what you're destructuring, you can actually use the underscore, which is kind of like, it's like a like a placeholder. It's like, yep, this is like a random variable, but I don't want to use it. I don't care. Like, this is just a formality to make clear what I'm doing here. Please don't worry about it. So in this case, I could do this. Now, naturally, you would use the for range loop for this. Obviously, you wouldn't use enumerate or indexes or whatever, but it's just an example. So now you have a look, and you know how's Pylint feeling about this. Missing module docstring. So generally speaking, if you get told a Pylint error, you can go and copy this error, because this is like a unique key for the error, and you can just Google it, and you'll find a whole bunch of links on it. But then typically you'll also find you know, actual docs information on it. Sometimes I find the Stack Overflow ones are more useful than the docs, because they're just a little bit more practical. But then I scroll down. Okay, a Python module's docstring documents what the contents of that file are. Okay, you can solve this by adding a docstring at the top of the file. Okay, that was really handy. That was really easy. Great, so I'll add this at the top of the file. The worst program ever. Then I run it, and 10 out of 10. Done. Perfect, right? Easy. Easy, easy, easy. That's Pylint in a nutshell. It tells you what semantic and style issues are, and it gives you an opportunity to go and fix those up. In terms of fixing them up, some things you're always going to have to resolve manually, right? Pretty much every linter that I'm aware of, it will not it's not able to fix everything for you, even if someone tried to. There's just some things that, while a linter can identify a problem, you know, it can't solve all of your problems, right? Like, I mean, this is true with a lot of things in life. I could look at your ID, and if it doesn't match your face, I say that's not your ID, and you're like, what's the right ID? And I'm like, I don't know. I just know that's the wrong one. There's a problem there. I don't know what the solution is. So some Pylint issues can be fixed, some linting issues generally can be fixed automatically. Some of them have to be fixed by hand. In terms of fixing things automatically, you can either... you can use tools for this. Now, Pylint, one of the frustrating things about Pylint is a lot of good linters out there actually have the self-fixing capabilities built into the linter. In the case of Pylint, that's not true. So typically, if you want to try and automate some of the like fixing some of the problems with your code, you can either use IDE add-ons like VS Code has auto formatters. I'm sure students will talk about it on the forum or something like this. I haven't used that one specifically, but there's certain add-ons onto VS Code that will actually fix up your code for you based on a Pylint configuration, which we'll talk about later. A command line tool that's also useful is AutoPep8. AutoPep8 is another pip installed external library, or runnable library, that will parse your code and actually fix it for you. So, like, to give you an example, I can show you that one right here. So if I, oops, whoa, okay, that's weird. I don't know why that jumped to that. So it's like if I, for a second, right, go, let's reverse this code back to where it was kind of ugly. Say like this. And you run Pylint on this, there's be errors, right? We get our negative 2.5 or whatever. If you pip3 install AutoPep8, this doesn't need to be part of your requirements.txt because it's not vital for your program to run. It's kind of like PyTest if you don't import it. It's just like a binary. It's just a program. So now when I run AutoPep8 on my file hello, what it actually does is it actually prints out my cleaned up code. You'll see that it has put spaces between the equals. It's put a space after the comma. It's removed some of the white space on the brackets. It's put 4 instead of 2 spaces there on the print. So all is well, but you'll notice the file isn't updated either, because the way most linters work is they take your file and they output it to the command line. So you can do something with it if you want to. However, if you would just like AutoPep8 to fix your stuff for you, you can add the -- in place command, and that will literally take the file, lint it, and override it on itself. So now when I click back on my editor, you'll see it's been fixed up for me. And my previous Pylint score of negative 2.5 is probably improved. Remember, it's now 2.5. sometimes it won't want to fix things, right? Like these two things, it's like that. It's just that's getting a little bit too far, and they might screw it up. Things like missing module docstring, linters are just not going to fix up. You're going to have to do that yourself a lot of the time. Is Auto Pep8 already installed on CSC servers? No, you can install it, but I just did it then. pip3 install Auto Pep8, done. Then it's installed and you can run it. Super, super simple. Yeah. It's not part of the requirements.txt that we give you, but that's okay. And to be honest with you, a lot of the time, like you should be linting super regularly. I think that one of the worst mistakes you can make is like linting, like not linting for days and then just linting at the end, because you'll just spend hours trying to clean up your code, which will be a bit of a nightmare. So yeah, that's kind of it there. Diorora says a docstring is necessary for really basic functions. If the style guide says to do them, they're going to be necessary. That's kind of the, it's kind of the simple summary. Someone asked before, what standard does Pylint work to? I won't lie, I actually don't know off the top of my head. I'm just not 100% sure. I don't know if it's PEP8 or some kind of variance of it, but this is the second last slide of the deck, and this will kind of touch base on a little bit of what the rules are, because it's like, oh, I don't know what the rules are. But with Pylint, when you just run Pylint file, it just runs the default Pylint on it. But it's like, what is the default Pylint stuff? Right? Like when you run Pylint, what rules is it applying? Because it's not it could change. So one easy way to check what rules it's doing is if you do Pylint, but instead of giving it a file, you do dash, is it this, was that it? Generate RC file. You do generate RC file. You'll actually get an output that is all of the Pylint config that it's using by default. So Pylint has a configuration that exists by default, and you can override that configuration relatively easily if you'd like to. But the default configuration can be found just by doing this. Now you might be thinking, okay, well, how do I override this configuration? What if I don't like a rule in it? Well, if you do Pylint generate RC file, you can actually output that file to a file called Pylint RC. Now, typically, this file will be put in a Git repo at the root level. But let's just say for now I have my Pylint RC file, and when Pylint runs, what it does is it looks for a Pylint RC file in your directory, and if it can find it, it will apply those rules, and if it can't, it will use the default one. So now when I run Pylint on hello.py, and let's say put some 2 spaces back so we get down to like 0 or something, it will use the Pylint RC file, and if I open the Pylint RC file, and let's look for indentation, here you go, here's a rule, indentation after parentheses. I don't think that's what we want, so we'll look for another case. Let's just look for an equals 4, or is that it? I don't know, let's try changing this one. So we're going to change our configuration, run Pylint, still at 0, so I've done something wrong there. Maybe spaces, I don't know where this particular rule is. Let's play around with another rule, unless someone else remembers what it is off the top of their head. So you notice there was this one here that was like maximum line length. Well, let's say you believe in really short lines. In fact, you believe in 20 character lines, something really short. That'd be crazy. You run Pylint again, our score's gone down now because lines 2 and lines 3 are considered too long now. So you've actually changed that rule. So Pylint RC has a general default thing. I don't know if that's PEP8 compliant. I'm sure it's pretty close to PEP8 compliant. I'm not gonna lie, we haven't used AutoPep8 before in the course. It's something I introduced this term, and I'm pretty sure that AutoPep8 won't correct anything that Pylint doesn't like. Though try it out, because I'm not 100% sure. It should be fine though. I did some testing last night, pretty rudimentary stuff, and every time I ran AutoPep8, Pylint was happy, so I'm sure it's fine. But yeah, so Pylint RC is what actually dictates some of the rules. Naturally, you don't need to rely on AutoPep8 or any add-ons. You can just fix these things up yourself. In fact, I would often encourage you to fix these things up yourself because it gives you a great intuitive understanding of what's going on. Because if you kind of just rely when you're learning about this stuff in your first year of uni on linters to fix everything, then like you lose out a little bit on just the thinking about things. So some other questions here. Waleed says, are we free to use any tools like AutoPep8 or Black that are common? So we don't care what tools you use to fix up your style. You could, if you have a really smart dog that can come and fix up your code, that's okay too. It's just that we're going to be marking you against Pylint. We're going to be marking you against Pylint. So whatever Pylint outputs, that's what your marks will come from. If you want to fix it up manually, use some plugins. Use something like Black, which is another lint fixer, or AutoPep8. That's totally up to you, and AutoPep8 is just something, again, that we've just suggested you use this term because it's useful, and students were asking previous term, how do I automatically fix these things? And there's your answer. So, yeah. The Hurlston says, is there any worries that making a automatic linting fix like AutoPep8 will change your code and break anything? No, so linters are very conservative. They only make changes that they know won't break your code. And that's why the fixers don't fix everything for you. That's why they won't just add doc strings in, because it might break your code. So they're actually very conservative. They're very safe to run, which is great. Now, you can also disable specific rules if you'd like to in Pylint. So like, let's say I'm running this code here and I get this like line too long thing. I can actually, on this line, say, I can write a comment at the end and say Pylint. What is it? Pylint. Yeah, I can then say : disable equals line too long. And if you add that to the end of the file, when Pylint is looking at it, it will actually ignore that line. So you see our score is actually going up. Now you might be thinking, why would we use this? We were told that the style guide needs to be followed. The short answer is you don't. We're teaching you this kind of for fun. But that also being said, there are the occasional instance that a student asks a question and they're like, I can't get this line to work. It's something really obscure about some random library. It's like super edge casey. And in some of those cases we say, it's okay, just Pylint disable that. But unless like your tutor has said you can do it, or you've gotten an okay by a staff member on the forum, we don't want you doing that at all. So don't play around with that. That's just more like if we say you can disable Pylint on that line, this is what we're referring to. Though that, I think last term that happened to like 2 students across the entire term for 1 line of code each. So it's really quite a minor thing. Yeah, and then in terms of your work from iteration 2 onwards, which comes out on Monday, I should make a note of that in my notices. Iteration 2, which comes out on Monday. I already did, great. And your lab 3s, you'll actually notice that Pylint is now part of those labs. So if I go and have a look, say at lab 3, I'm pretty sure it's in here, and we look at like a lab like tables, you'll actually, maybe only some of them have it. Maybe I'm mixing this up with week 4. Oh no, is it? Or do we just not have it in? Oh no, we just do coverage. Okay, sorry, I got myself mixed up here. Wait, there's another topic we talk about tomorrow that's part of week 3. Maybe we actually don't do linting much in the labs. I think I might be confusing myself. So maybe it's in lab 4. I can't remember, but in some of the labs, I feel like in some of the labs we've asked you to make sure your code's linted, which basically just means running Pylint on it. There we go. So like in lab 4 weather, we do have a Pylint RC, and at the bottom of the lab it says, ensure your code is Pylint compliant and that your tests have 100% code coverage. Okay, so there's a Pylint RC file here that we provide you with. And in iteration 2, we will be pushing a Pylint RC file to your repo. So please don't add your own Pylint RC to iteration 1, because you'll probably get a whole bunch of unresolvable merge conflicts when we push ours to your repo. Or if you do really want it, add it and then get rid of it just before you submit or something. So yeah, that's pretty much it. This pylintrc file is where all of the information about what to lint comes into play. So we'll see more information there. That's pretty much it on this lecture. Raman's asking, what's the command to download AutoPep8? It's just pip3 install AutoPep8. Many Python modules are installed just by pip3 install and then the name of the module. Easy. Okay, please leave some feedback on this lecture. That would be great. Thank you. Follow the link, the QR code. It's always good to get a reading. And we'll wrap this one up in a sec. So pause the video, please, if you're live or whatever. Just